Hello everyone, this is Trista. So today my talk is about how to do the traffic governance from your application to your database infrastructure on the Kubernetes. Before to answer this question, I will raise another question and the most request from all of our community. That is how to upgrade your existing monolithic databases cluster, maybe MySQL or PostgreSQL or Oracle or SQLServer, to make those databases cluster become the sharding architecture or make it become the distributed database architecture, right? And then to do the traffic governance. Because in the sharding architecture, the topology is so complicated, right? So I'm Trista Pan, the Sophia co-founder and the CTO. My area is around the database mesh, the database distributed database, about the database management AI platform development. Because I'm a developer and spend a lot of my time and efforts in open source, especially in Apache Software Foundation. So now I'm the mentoring two incubator Apache project and be the member of this Apache Software Foundation. Sometimes I will post some articles or some about the business or startup or open source or the databases, cloud stuff on my Twitter linking. If you're interested in such topics, please give a look there and let's discuss all the stuff there, right? So today, our content will include the following item parts. The first one, give the brief introduction about the background. The second one, let you found the new requirements for the databases on cloud. The third one, I will give the architecture and the solution. The next one will dive into a SQL life cycle of this in this distributed database system. Then, if I have enough time, I will give the detailed introduction about the demo, right? So, first part is the digital transformation. It's so popular these days, right? Because people really want to leverage all of the novel technologies to upgrade their infrastructure or think out of some new ideas to service their customers and users efficiently and effectively, right? So it's not just about how to do the change about your infrastructure, about your from the development to your delivery paradigm. It's also about the culture change or mindset. So that's the background. In this background, how about the database? Because all of the changes will raise the new requirements about our infrastructure, about our databases. And currently, from our community and from my experience, that people have the following major concerns. The first one, how to manage and store so much data, right? The second one, how to make each request to be answered as fast as it can. The third one about how to do the traffic governance, because as I said before, especially in the distributed database system, there are complicated topology among your different computing nodes, your application, and your storage nodes, right? So we hope that someone or some application platform to help us to deal with all of the topology. And then we'll consider elastic scaling, that means scalability for our future scenarios and future data, right? Then if there is an out-of-the-box solution or deployment or tools, that would be perfect, right? So to answer the following questions, I will give my answer about each of them. First, large data to manage and efficient queries and all of the needs, I will give the data sharding answer. The next one, about the check governance, based on the data sorting architecture, we can do the high availability and rewrite splitting, or other like the SQL audit, or based on some metrics to do the traffic strategy, all the stuff. Then about elastic scaling, that means we can help user to research their computing nodes and storage nodes of a distributed database system. Later on, I will give some the introduction about such part. And then, thanks to the Kubernetes, we found that the microservice application works so well and effectively on the Kubernetes. So could we use the similar primitives or other tools, or use the similar mechanism on the Kubernetes to help manage our databases or data? Is possible? I think it's possible because most of the companies are working on that way, right? All right, so how to do that part? How to help us to include all of the solutions into one and just to give the out-of-the-box solution to help a user to adopt it. Before give the solution or the answer, I need to first give the background of database system. Let us see this architecture again to consider about the databases, because if we can know the fundamental of the database system, then we will have the better way to solve the issues I mentioned before. First, I want to say that here, a database system, actually they made up two parts. First one is computing nodes, right? The second one is storage nodes. That means our database, no matter it's a distributed one or a monolithic, they have these two parts, so important capabilities, right? But for the distributed database system, they just split the computing nodes and storage nodes separately and deploy them in different locations. So that means this database become a distributed one. But whereas our monolithic databases, they merge the computing capability and the storage capability together. So you can just one common to deploy this single, database instance consisting of computing nodes and storage nodes together in one machine, right? That's the difference between the monolithic and the distributed databases, right? So today we will think the solution in this way. We could consider that if we already have the MySQL or PostgreSQL here, right? That's where your databases cluster, existing database cluster, right? So could we just regard such monolithic database as the storage nodes of a new distributed database system, right? And we can just, we don't do any change to our existing databases, don't do any dangerous action on them, just import the computing nodes in this system, right? So these computing nodes can work as a database server, right? If your databases, it's the MySQL or Postgres, right? So now we can make those storage nodes become the local storage nodes. Become the local database instance. And we can just import the global, computing nodes working as the database server. Then the computing nodes plus the storage nodes will become the distributed database system, right? So in that way, we can upgrade your existing database, become a distributed one. So the next part is Sharding Sophia. Sharding Sophia, it can work as this role. It could be work as a database proxy or database, pretend itself as a database server, like the MySQL server or PostgreSQL server. So if we import sharding Sophia here and working as a computing nodes, and it will connect to different database instance, that means the storage nodes of this new database distributed database system. And sharding Sophia also have the governance node to help us synchronize all of the metadata change among different computing nodes. I mean sharding Sophia. Then we can, by this way, upgrading or existing monolithic MySQL cluster or PostgreSQL cluster become a distributed MySQL cluster or PostgreSQL database cluster, right? Another benefit from this solution that because we adopt the computing and storage splitting architecture, so we can do the reshard on computing nodes or storage nodes. That means sharding Sophia or store your databases independently, right? If you, at this point, if you found that you need more computing power, then you can just spin up more sharding Sophia proxy or sharding Sophia. So that means you can have more computing power, computing nodes working in this distributed database system. But another aspect that some users found, they need more storage capabilities. Then you don't need to spend too much time, effort, money on such computing nodes. You can, create more database instance, right? So here maybe 1, 2, 3, maybe there are 4 or 5, 1, and sharding Sophia can connect to the new database instance and to help you reshard your original data among 1, 2, 3, the old and the new one. The new storage nodes, your new PostgreSQL nodes will contain the data and resharded by sharding Sophia. So that's the benefit of this solution. The next part lets us know more about this role, computing nodes, Apache sharding Sophia. So Apache sharding Sophia, why do I say that it can help us do that work? Because here, sharding Sophia, it's an ecosystem to transfer any databases into distributed databases and enhance it with a sharding feature, elastic scaling feature, data encryption feature, or more, right? So from the slogan, it looks like everything can work well. And this project also have a strong community to help us to answer some questions. And because now you can see here in the statistic on GitHub, more than 17,000 stars and released for nearly 15 times, and also have more than 400 contributors there, right? So that means you don't worry that you will be the first person to use the project. You don't worry about the monolithic, all about the issues about this community, because your issue maybe has been found by others, by this community, right? So it's a mature community and mature project for us to use. And his document is so detailed, and to help us enter his concept, help us to set up this ecosystem or the solution. So sharding Sophia provides two clients. The first one is sharding Sophia proxy. The next one is sharding Sophia JDBC. But like I said before, the sharding Sophia proxy, it can work as the computing nodes. Actually, sharding Sophia JDBC is the same, but today we will use sharding Sophia proxy to do our demo show. And so you can see here, sharding Sophia proxy can visit MySQL or PostgreSQL or RDS databases. So that means sharding Sophia proxy can help us manage your database cluster and also can upgrade, make it become the distributed one, and help us to do the traffic governance and to help us manage the complicated topology of your distributed database system, right? Because all the application will first send the request to ShardingSphere. ShardingSphere do a lot of computing, global computing, and to target which database cluster have the expected data, and then do and merge the different local readout side to become the final one and to return to our end users. And also another benefit that it can help us to do that the read-write splitting. That means because your database is like this, the first database instance, maybe it will have a lot of replica for this shard, right? And have many replica for the second shard, and have replica for the third shard. And then the ShardingSphere will to judge this request, this SQL, it's a select SQL or a DML SQL. I mean the update or insert. So it will automatically route the SQL to different primary nodes and its replica. You can choose to random route the request to the replica or to use other strategies. But the main target of or main work of ShardingSphere proxy or JDBC that it can help you to leverage your replicas performance and your primary nodes performance to make the throughput to be improved. So that's the benefit of ShardingSphere. Right. So the next part that I will give the final solution here. ShardingSphere provide the ShardingSphere charts, and you can use the Helm by one command to light the Helm to help you deploy in ShardingSphere cluster in this Kubernetes. And also today, if you already have your PostgreSQL instance, that's okay. You can ignore this part. But today I want to give this complete demo. So I use the PostgreSQL charts to help me to deploy 2 PostgreSQL instance here. So now on this Kubernetes, we have the computing nodes, we have the storage nodes, and computing nodes plus the storage nodes become the final distributed database system or application can just send the request to our ShardingSphere proxy, and ShardingSphere proxy will help do the do shard data sharding or read-write splitting or SQL audit or authentication or authority, such stuff. So that's all the features of ShardingSphere. Right. So, you can see here or the application just send the request to ShardingSphere proxy, and ShardingSphere proxy will help us shard data, read-write splitting, and to guarantee and to found that maybe there are many replica. If ShardingSphere found the primary key crashed, it will send the request to our replica ones. Right? So that's the ShardingSphere proxy function. And ShardingSphere governance will help us to synchronize the metadata among different proxy. And the ShardingSphere operator, it helps us to guarantee the high availability of ShardingSphere proxy, and also to do the elastic computing node skew in or skew out. So that's the ShardingSphere operator. It's like the DBA on the Kubernetes to guarantee this distributed system. Another point I want to say that PostgreSQL or MySQL, its self availability, we need to other tools to guarantee its availability. But ShardingSphere could be aware of the different roles of the databases and to help to route or reroute the traffic to different the PostgreSQL instance. So, but today I have no enough time to give more details, but I will give the final part. Let us to see that how about the SQL. So here, when the application sends a request to SQLServer proxy, SQLServer proxy will use the sharding algorithm to find which databases contain the expected data, right? And to gather the data from the database instance and to the SQLServer proxy and merge the local readout site and to return them to our end user. But another way that it will also to judge or to evaluate, like here, it's a select SQL, right? Select statement. So SQLServer proxy will automatically send the select statement to the replica ones, not the primary ones. Also, you can to light SQLServer to help you to send the request to the primary ones or replica ones. That's okay. It's up to you. You can just write the YAML file to tell SQLServer to do such stuff. But all of the change statements, I mean insert or update or create, it will automatically send all of the change data statement to the primary ones. So primary ones will synchronize the changes to their replica. So that's the clear now, right? Okay, so the demo show have no time to give the one by one, step by step the demo, but you can refer to my steps to create or to test that solution. All right, so see you next time. And if you also have any questions, just contact me on my Twitter, GitHub, or LinkedIn. And that's all. So see you.